Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Fogzilla by Megan33, and here are the rules. We have normal Sudoku rules apply, which means place a single digit in from 1 through 9 in every cell in the grid such that there are no repeats in any row, column, or designated 9-cell region. That is a box in this case. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. No guessing is required. So if you place a digit correctly here, it would clear the fog in that cell and in the 8 surrounding cells touching it. And that's how fog of war works. We also have adjacent digits along a green German whisper line must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9, because those are the only digits that are 5 or more away from 3. And that's how German whisper lines work. We have digits along a magenta renband form a set of consecutive, non-repeating digits in any order. So this could be something like 3, 4, and 5. That would be valid. Or you could have something like 8, 9. Well, okay, that doesn't really work. 9, 7. That doesn't work either. Let's have then 8, 6, and 7 here. Those are all consecutive. Actually, that doesn't work either, but well, whatever. And that's because of the restrictions, but that's an example of how renband works, right? These form a set of consecutive, non-repeating digits in any order. We also have a black dot between cells indicates cell values with a 2-to-1 ratio, and a white dot between cells indicates cells with consecutive values. Not all dots are given. So these are called Kropke dots. We have a black one here. So if this were, for example, a 2, this would have to be a 1 or a 4. Let's just imagine this was a white Kropke dot here. If this were a 6, then this would have to be a 5 or 7, assuming that this was a white Kropke dot, because those are the only digits consecutive with 6. And that's an example of how Kropke dots work. And then finally, we have adjacent cells connected with an X must sum to 10, and adjacent cells connected with a V must sum to 5. So for example, if this were a 3, this would have to be 7 because these two digits add up to 10, and this would have to be a 2 because these two digits add up to 5. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, so these digits add up to 5, so it's either 1, 4, or 2, 3, which means this correspondingly is 6, 7, 8, or 9. These can be from 1 through 6, but this can never be 5 or 6 or 4, right? Because 4 can be in a renband with up to 5 and 6. That's it for 3 digits. But if this were 6, it's between 2 unique digits on a German whisper line, which is not possible. If it's 4, it would be next to 2 unique digits on a German whisper line, so it can't be 4 or 6. And 5 can never be on a German whisper line, because 4 is only next to 1, can only be next to 1 digit on a German whisper line. That's 9. 6 can only be next to 1 unique digit on a German whisper line, and that's 1. And 5 can never be on a German whisper line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So this must be 1, 2, or 3, which means these digits have to be 6, 7, 8, and 9 next to it. If this were 6, it would have to be on a renband with 4 and 5 with these combinations, and 5 can't be here or here, so this can't be 6. 5 cannot be next to a black Kropke dot, because if it were, then 5 would basically, 5 is double of 2.5, which is not a normal Sudoku digit. And if you double 5, you get 10, which is not a digit. So 5 can never be one of these two digits. So we have a 1, 2, 3, 4 quadruplet in the central box, which eliminates 1 through 4 in the rest of the box. This must be 6 through 9, 5 through 9 technically, but as I said, 5 doubled. If you double a number to get to 5, you get 2.5. If you double 5, you get 10. So 5 can never be next to a black Kropke dot. So this must be 5 here. This has to be a 6 or an 8, because that's double of 3 or 4. This is 3 or 4. One of these two digits is a 3 or 4, so this cannot be 3 or 4 here. This must be 1 or 2. If this were 1, that forces this to be 1, 2, and 3. If this is 2, it has to be 2, 3, 4, and this is... So if this is 1, this has to be 1, 2, 3 as a Renban. So it would be 1, 2, 3 as a Renban. If this is 2, this would be a 1, 4 pair here. So if this is 1, this must be 2, this is 3, and this is 6. If this is 2, this has to be a 1, 4 pair here, which means this would still have to be 3 here. And that would be 6. So we know this is 3, this is 6. 6 obviously cannot be any of these. 6 can't be here, so this can't be 4. This is 8 or 9 with 1 or 2 here. This must be 3 or 4. 3 eliminates 3 here, so this is 4, which makes this 1 and 9, which makes this 2 next to 7 and 8. This digit is next to 2 unique digits on the German whisper line, and it can't be 1, 2, or 3, so 4 is also eliminated, which forces this to be a 7, 8, 9. 7, 8, 9 is next to 1, 2, or 3, or 4 on a German whisper line, but this can't be 4. This 1, 2, 3 is consecutive with only 1, 2, 3, or 4 here, which makes this 6 through 9. This can't be 9, so this can't be 1. This 1, 2, 3, 4 adds up to 10 with a 6 through 9, so this must be 5 through 9 here, but it can't be 9. This 6, 7, or 8 is consecutive with only 5 through 9. 5 and 6 can't be here because of the 5 or 6 in the row. This then has to be 7, 8, or 9, and it's the only digit that's in a 1 to 2 ratio with another digit is 8, because 7 and 9 are double of 3.5 and 4.5, which are not digits. If you double 7 and 9, you get 14 or 18, which are not digits. So this must be 8, which makes this a 4. 8 is only consecutive with 7 out of 6, 7, and 8. So this is 7, this is 3. 3 is consecutive only with 2 out of the possibilities here. So this is 2. This can't be 2 or 3, so this has to be 1 or 4 with 6 or 9. 6 or 9 is on. This can't be 7. So if this is 6, it would be consecutive with 5. If it's 9, it's consecutive with 8. These are two digits adding up to 10. You can't have 4, 6 here, so this can't be a 4, 6. You can't have 2, 8 here. It's either 1, 9 or 3, 7. And this can't be 1 or 3, so this can't be 7 or 9 here. This is 1 or 3 here. These are consecutive. If it's 5, it can be 3, 4, 5, 4, 5, 6, 5, 6, 7. If it's 8, it's 6, 7, 8, or 7, 8, 9. So that means these digits can never have a 2 or a 1. So it's 3 through 9. This can't be 3, 5, 6, or 8. This can't be 4, 7, or 8. So it could be 3, 4, 5. That's fine. You cannot have 5, 6, 7, because if this is 5, this would have to be 6 here. And of these digits, what digits here can be in a 1 to 2 ratio with another digit? Can't be 5 and 9. This is 3, 6. So this must guarantee this digit is a 3 or 6. Then you have a 3, 6, 3, 6 pair in column 3, which eliminates 3 and 6 in the rest of the column. So this can't be 6. This is 9, which makes this 8. So this must be 8, 7, 6 because you can't have a 9 here. So this is 7, this is 6, this is 3. The 9 and 1 add up to 10. This can't be 9. This has to be 7 or 8. This can't be 1, so this is 3, which makes this 7. This can't be 7 or 9, so this is 8. This cannot be a high digit because we have all the high digits in the column. So this is 1 or 2 because it's next to 2 unique digits on a German whisper line. This is a high digit. It's next to 2 unique digits on a German whisper line, so it's 7, 8, or 9. This is a low digit. It's next to 2 unique digits on a German whisper line, so it's 1 or 2. This then can't be 6, 7, or 8. It must be high, so this is 9. This can't be 9 here. This has to be 6, 7, or 8 here because it's a high digit. And you'll always alternate between low digits and high digits on a German whisper line because the digits 1 through 4, which we consider low, have to be next to, 1 can only be next to 6 through 9, 2 can only be next to 7 through 9, 3 can only be next to 8 or 9, and 4 can only be next to 9. So if you have a low digit, which is 1 through 4, it will always be next to a digit that is from 6 through 9, which is a high digit, and vice versa. So that's the reasoning how we figured these out here. Let's see. 7 cannot. Okay, these digits are 1, 2, 4, and 5 remaining in column 3. This can't be 1, 2 because of the 1, 2 pair in the box. So this red band could be 1, 2, 3, but there's no 3 possible. So this cannot be 1, 2, 3. It can't be 2, 3, 4 for the same reasoning. It must include 4 or 5. So it could be 4, 5, 6, or 5, 6, 7. So this is 4, 5, 6, 7. 7 obviously can't be here. 5 has to be one of these 3 digits. And 6 has to be one of these 2 digits. Because you can only have 4, 5, 6 or 5, 6, 7 because 3 is not allowed in either of these rows. 3 has to be one of these 2 digits here. This is a 4, 5, 4, 5 pair, which eliminates 4 and 5 in the rest of the column. So this is 1 or 2. 5 is one of these 3. 6 is one of these 2. What are the remaining digits in row 3? We have 4, 5, 6, 7. Remaining digits in row 4, are 2, 3, 5, 6. And this can't be 6 here. Rest of the remaining digits in row 5 are 1, 2, 4, 9. So these can't be 9. 1, 2, 4, 9. And 4 cannot be here. Remaining digits in row 6 are 1, 3, and 5. Okay. 9 cannot be here. So 9's one of these 3 digits, but that's not helpful. Okay, this is 3, so this cannot be 3 here. We know on a 5-digit Ren band with a 3, it's either 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, or 3, 4, 5, 6, 7. So you'll always have 3, 4, and 5 on the Ren band. So 4 has to be one of these 2 digits here. 3 digits here. 5 can be any of these 4. So we know we need 4 here, and 5 is one of these 4. This cannot be 4 then, because 4 has to be one of these 3. 4 obviously cannot be here. So 4 is one of these 2 digits here, which means 4 has to be one of these 3 digits here. What are the remaining digits in box, in the upper central box? It has to be 4, 5, 6, and 9. This can't be 5, 9, so this becomes a 4, 6 pair, which eliminates 4 and 6 in the rest of the box and the rest of the column. So this can't be 6. That makes a 7, 8 pair, which eliminates 7 and 8 from the rest of the column. So this has to be a 2, 3 pair, which means this can't be 3 because of the 3 in the row. So this is 2, this is 3. This 2 eliminates 2 here, so that's 1. This has to be 2 then. The 2 is next, that eliminates 2 here, so this is 1. 1 is only consecutive with 2, so this is 2, this is 3. That's 3 in the corner. We celebrate. We have a 4, 5, 6, 7 quadruplet in this box, which eliminates 4, 5, 6, and 7 from the rest of the box, so this is 8. We have a 4, 5, 6 triplet, actually, in row 2, which eliminates 4, 5, and 6 in the rest of the row. Therefore, this must be 1, 2, and 9. Well, 9 can never be on a Ren band with 3 of 5 length, so this is 1 and 2, which forces this to be 9. That means this has to be 4 and 5, to be 1, 2, 3, 4, 5. So this is 4, this is 5, which eliminates 5 here, 5 here. We have, where is the 6 in row 4? It has to be here. The 5 is eliminated from here. This can't be 9 either. Where is the 9 in this right central box? It has to be here. So this is 9. This 1, 3, 1, 3 pair eliminates 1 and 3 in the rest of the box. So this is 2. These can't be 2. This is a 1, 4 pair. 1 eliminates 1 here. So this is 4. This is 1. That eliminates 4 being here. 4 also cannot be here because of the 4 in the row. So where's the 4 in this upper left-hand box? It has to be here. So this is 4, which forces this to be a 5, 6 pair, to be a Ren band. Therefore, that eliminates 5 and 6 in the rest of the box. So this is 7, which means this can't be 7. This 2 eliminates 2 here, so this is 3, this is 2. We have a 7, 8 pair left in column 2. This 4 eliminates 4 here, so this is 5. This isn't a 1 to 2 ratio. It cannot have 2 or 3. That eliminates 1, 2, 2, 4, and 3, 6 as possibilities. So this has to be 4 and 8. 4 cannot be here because of the 4 in the column. So this is 8, this is 4, this 8 eliminates 8 here. So this is 7, this is 8, which makes that is 7. Which makes that 8, which makes that 7. This can't be 1 or 3, so this is 5. This 4 eliminates 4 here, so it's 6 and 4. Remaining digits in the lower central box, it has to be 1, 5, 6, and 9. 1 cannot be here or here. Where is the 1 in this box? It has to be here. 6 cannot be here. This is 5 or 9. 5, 6, or 9 here. This 6 eliminates 6 here, so this is 5. This is 6. This is 5. This cannot be 1, 2, or 3, or 4, so this has to be a high digit. So this is 6, 7, or 8. This can't be 1 or 2 as a low digit. It has to be 3 then, because it's in between 2 unique digits on a German whisper line. So this is 3. This has to then be 8. This is a 9. This 3 eliminates 3 here, so that's a 1, which makes that 3. 1 eliminates 1 here, so that's 2, which makes that 1. 4 cannot be here. 3's here. We have all 3 3's. What about 1's? We have 8 1's. We know where the last one has to be. It has to be here. 2's. 2's, we have 8 2's. We know where the last 2 has to be. It has to be here. 3's, we have 9 3's. 4 can be either of these. So that's still looking, we're looking at that. 5's. 5 in this lower right-hand box cannot be here or here because of the 5 in the columns. So 5 has to be here, which makes this 9, which makes that 6, and therefore that's a 5. So this is all the 5's. This 5 eliminates 5 here, so it's 9 and 5. So we have all the 5's left now. 6's. In the lower right-hand box, 6 cannot be here, so 6 must be here. And that gives us 6 can't be here, 6 can't be here because of the 6's in the column, so 6 must be here. That gives us 8 6's. We know where the last 6 has to be. It has to be here. 7's. 7 can only be in the lower right-hand box here because the 7 is eliminated here by the 7 in the row. So this is 7, this is 4. That gives us 8 7's. We know where the last 7 has to be. It has to be here. We have 8 eights. We know where the last 8 has to be. It has to be here. 9s. We have 8 9s. We know where the last 9 has to be. It has to be here. And that forces this to be a 4. And that's a solution. Yeah, sorry, I didn't clarify why German whisper lines had to be low, high, and low. But that's a very important use of German whisper lines to restrict certain cells. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.